Welcome back, boys, for part 2 of lesson 7.9, multiplication of binomials containing radicals. So just to refresh your memory, so part 1 was when you had two binomials that contain radicals and you were to multiply them, and all you had to do was FOIL, and you learned a new word called the conjugate. And when you multiply conjugates, you will always get an integer, and that's not going to change in part 2. So this part 2 deals with rationalizing denominators, which is something we did in a previous lesson. But now it's going to contain a binomial, which is a little bit different than just rationalizing it with just a single radical. Okay, so we're going to do a little review, and then I believe we have 4 examples. So for our review, so if you remember before, this was a problem I gave you, and what was wrong with it, and some of you recognize that, is you can't have a radical in the denominator. Whereas some of you left this as an answer, and you got it marked wrong, this is not fully simplified. So if we were to multiply, or if we were to rationalize this, you should remember to multiply by a value of 1, which I chose the radical of 5 over the radical of 5. And no, I did not just pull that out of thin air. You look at this number and you put it over each other. So this is just a value of 1. It is not changing the problem in any way, shape, or form. So there's a 1 outside here. 3 radical 5 over radical 25, which simplify the bottom, and now it becomes a 5 versus a radical of 5. And this cannot be reduced, but you should just look at this 3 and look at the 5. Can't reduce, so you move on. So this is something that you should remember. So we're going to pretty much do the same thing now, but the denominator of radical 5 right here is going to contain something else, like this. So what would you do if you get a problem like this, which is pretty much your entire assignment for today? So in order to do this problem, you realize that it's not correct because of this radical of 7 in the denominator. But it's not just a radical of 7, so you can't just do this. That doesn't eliminate everything. You have to consider this entire quantity. It's glued together by that minus sign. So what I just did is not possible for this problem. So what we use is, we use the conjugates. So conjugates can be used to rationalize binomial denominators that contain radicals. So for this problem, if you remember conjugates, they differ only in sign. So for this problem, it would be 2 plus radical 7 over 2 plus radical 7. You are changing only the sign. Numbers stay the same, which they did before, but you have to include everything and then just change your sign. Now, in Big Ideas, they use a different word other than conjugate. So just to give you a heads up, when you see this on Big Ideas, which you will, I believe it's the first few examples or problems, it's called the rationalizing whatever factor. That's just another name for conjugate. So for the first few problems on Big Ideas, it does not want you to solve. You would just put this right here as the answer for that. It just wants you to name the conjugate. And then the next few problems in Big Ideas are ones where I want you to do the problem and then give me the final answer. Okay, so just remember, this just means give me the conjugate. All right, so this problem looks very similar, but now we're actually going to do it. So if you remember, the conjugate would be 2 plus radical 7. So I'm going to put that in parentheses. And 2 plus radical 7 over 2 plus radical 7. So 1 parentheses 2 plus radical 7. I'm just going to work on the entire numerator first. So arrow, and then there's a 1 out here, so this one would be multiplied by that one. So you get 2 plus 1 radical 7. Radical 7 did not have like a buddy, so it stays the same. Now, the denominator, you need to FOIL this. And because they're conjugates, it's going to equal an integer. So I'm going to do all this work down here. So we're going to get 4 plus 2 radical 7 minus 2 radical 7 minus 49. Your two middle terms are going to cancel because they're opposites. So we're going to get 4 minus 7, which is an integer of -3. So -3, -3. Now I'm going to box it. However, you should be looking at this 2, this 1, and this 3. If there was a universal number that you could reduce all 3 numbers by, you would. You can't just choose, oh, I'm going to look at the 2 and the 3. No, you have to look at all 3 of these numbers. The radical of 7 never does anything. It's going to stay as it is. Okay, so this one you cannot actually reduce. Okay, so for this one, the conjugates in the denominator's in a different order, but it doesn't matter. So the conjugate would be square root of 5 minus 2. Remember, conjugates only differ in sign. So let's do the top. So 3 parentheses radical 5 minus 2. Don't forget there's a 1 right there. So I'm just doing the entire numerator. So this would be 3 times the 1 and this 3 by the 2. So 3 radical 5 minus 6. Looks like the bottom we need to FOIL, and we better get a whole number if we do it correctly. So radical 25 minus 2 radical 5 plus 2 radical 5 minus 4. Two middle terms cancel. So 5 minus 4 is going to equal a 1. Now, obviously, boys, I am doing it the long way. So if you FOIL this, you will automatically know that the O and the I are going to cancel. So all you would have to actually do is the F and the L in the FOIL process. So just to save you some time. So our new denominator is now a 1. Well, that's easy because you don't need the 1 and you can't reduce anything. So there's your final answer. Okay, let's do this one. You have 3 over 5 minus 2 radical 7. And if you notice, all of these numerators have just been whole numbers. And our last example, it's probably going to be the most difficult because it's going to be more than just a whole number. So the conjugate for this problem is 5 plus 2 radical 7. And finding the conjugate is always the easiest thing. It's just knowing what to do after that. Okay, so let's do the numerator. So we got 3 parentheses 5 plus 2 radical 7. So arrow, arrow. Notice the radical 7 is going to stay. So we're going to get what? 15 plus 6 radical 7. And we're going to need to FOIL the bottom. I'm going to do that down here. So you get 25. Plus, careful, you're going to get 10 radical 7 minus 10 radical 7 minus 4 radical 49. So these are going to go away. You're going to have 25 minus, now it's going to be 4 times 7. If you remember PEMDAS, do it over here, it's going to be 25 minus 28. Which is going to be a -3. So that is your new numerator. Now, we are almost done. You need to look at, like I said earlier, these 3 numbers right here. You have a 15, 6, and a 3. Now, I do believe that there is a universal number that you can divide all 3 of those numbers by. So we are going to reduce by 3. So this is going to be a 5. This is going to be a 2. Radical 7 stays. And this would be a -1. Now, technically that is correct. But if you were to put that in Big Ideas, it could mark it wrong. Because usually you never have a denominator that has a negative. Usually you just see a 1. So technically we need to actually fix this. So I'm going to bring this negative up here, bring that negative up there. So my final answer would be negative 5 minus 2 radical 7. So you're just distributing the negative to the top. Now, if that was a positive one, well, nothing would need to be changed. Okay, so just again, that both of these answers are the same. It's just this one technically is not fully simplified, so you would have to probably put that into big ideas for it to accept it. Okay, all right, now we have the most difficult one of the day. There we go. So if you notice the fact that you have another binomial in the numerator, so this will get ugly. So let's start with the conjugate. Conjugate is 3 plus radical 5. Oops. Okay. And everything is going to need parentheses. All right. So for the numerator, like we've been doing, the numerator, well, looks like we're going to have to FOIL that. So let's do that at the top. So you're going to get, what, 12? If you do 4 times 3, plus you get 4 radical 5 plus 3 radical 5 plus radical 25. Now, nothing's going to cancel, so you're going to, let's do this. So this is going to be a 5, and you have your 12. So it looks like you're going to have, what, 17 plus, and if you remember, this radical, these have the same radicands. That was from a different lesson. So you're going to do 4 and 3, which makes 7, radical 5. In order does not matter at all. So that's the numerator, okay? Now, the denominator, we should be getting a whole number because you're multiplying conjugates together. So let's FOIL this. So we get, what, 9 plus 3 radical 5 minus 3 radical 5 minus radical 25. Those are going to cancel and get 9 minus 5, which is just a 4. 4. Wow. Well, let's box it because I do believe that you have a 17, a 7, and a 4. There is no universal number other than 1 that can be divided into all 3 of those. So that is your answer. So that's pretty much the most difficult that they can get. Just with saying that the numerator, that the numerator just ends up to be a radical, whereas your denominator will always be an integer. So that's probably the hardest part. Okay, so you feel free to rewatch this video and go to Big Ideas and do, I believe there are 8 questions on Big Ideas. And don't forget, remember, some of the questions only want you to use the conjugate. So if you start getting it wrong, you didn't read the directions. All right, good luck, boys. See you next time.